everyone. I Neha Thakkar, Assistant Professor at New LJ Institute of Engineering and Technology. In last lecture, we have started with the Unit 6. Today, we are going to move to the next topic of that one. In last time, we have seen that what is the use of indices, why we are going for the indices. The next question is how it is going to be stored, which data structure we need to use for that. So today we will discuss about the B tree. So first we'll see what is the meaning of tree. So tree is a non-linear and a hierarchical data structure, and that will consisting of what? The nodes. That means tree is nothing, it's a collection of nodes. It have a root value, it's having a subtree, and it's having a leaf node, right? So this is the general definition of tree. Now what is B tree? So B tree is a self-balancing tree. As we have seen in the indices that if you want to search anything, then if you have used a sequence index or a single index, then you have to go for entire database. So we have moved what? There are ordered indices are there, multi-level indices are there. So we need to use that one. So multi-level indices, that means what? If there is a large database is there, and we know that the frequently we are going to use a read and write the data. So at that time the searching is nothing but what? The searching of the data is going to be that. So if we are going to use this one, then it will be very easy for us. So this is commonly going to be used by a database and a file system. So this is the use of B tree. Now we have seen that multi-level indices is having what? The level of entries are there. Say example here 10 lakh records are there. So again it's not going to be stored in a, we can say the, and it is not going to be refer or a pointer by a single index. Multi-level indices is going to be that. Here there is a 10,000 records. Here there is an entry of what? 100 block is there. Each block is again pointing to the another 10,000 records, or we can say the 100 records. So total we will be having that 10,000 record. Again that block is having a entry. 100 block is having the entry into the upper block. So this is nothing but what? A tree structure. So we are going to use a B tree for that purpose. So this is, you can see the B tree. So this node is called a root node. This are called a leaf nodes, and this is non-leaf node. So you can see that how it is arranged. 30 first is, so whatever here, that is all values are what? Less than 30. Here it is in between 30 and 70, and here it is between, or it is what? Greater than 70. So we can say that if you want to search any element, say example 21, so directly we'll check here, is it less than 30? Yes. So just we will search in this subtree only. So in this way it will work. So it will have a less time to access the data instead of if we'll go for the sequence and the whole database. Now some properties are there of the B tree. So B tree is always having some order. For example, create a B tree for the order 4 or a order 5, like that. So it depends upon the order. So every node has at most m children. That means suppose m is 3. So at most 3, maximum 3 children can be there. Every non-leaf node, these nodes are a non-leaf node. So have at least what? A scale of m by 2 child node. Suppose m is 4, so it has what? At least 2 children. A non-leaf node with k children is having or keys, that is k minus 1. Here there are 3, we can say childrens are there, so it will be having 2 keys. So in this way the B tree will work. Now we will see one example to construct a B tree of a order 3, and the data is this. We can see that the data is not in a sorted form. So while we are going to enter the data, first we sort it and then we are going to store into the tree as a node. So first is what? A 20. So how it is going to be enter? Right now there is nothing in a tree, that means the tree is empty. So we'll just create a root node and assign the 20 into that. The next is what? 10. So we know that order is 3. So at a particular node 2 key is a possible. Now 10 is less than 20. So we know that how the 10 is going to be stored, that is before the 20. So 10 and 20. The next will be 30. So here the 30 is there. Now 30 should be here after the 20 because it is greater than 20, right? It is should be in a some order. So now the 3 key cannot be possible. So what we need to do, this 20, the middle one is going to be up. So the B tree is always growing up. So first we'll create a 20 as a root node, okay, and the 10 that is of the left side of 20. So 10 will be here and 30 will be goes here. So in this way it will work. So 30 we have added. Now next is what? 15. So where it is going to be added? So 15 is less than 20. So it goes to left side and it is going to be accommodated with 10 because at that 2 keys can be possible. So just we'll go for now a 15. So 15. Now already we'll be having root as a 20. Then 10 and 50 is going to be together. 10 and 15, and light side it is what? 30. So next is what? 12. So where it is going to be stored? So we know that 12 is what? Less than 20, so goes left side. 12 is going to be in between 10 and 50, but 3 key are not possible. So the middle one is new added, that is 12. So 12 will be moved up and it will be combined with what? 20. So just will reconstruct it 12 and it should be here a 20. Then here it is 10. Now 15 cannot be here because 15 is in between 12 and 20. So just will do here, add here 15 and then it should be here, that is what? A 30. The next is what? A 40. So 40 can be where? That is just next to 30. So just we'll draw it in the next slide. That is 40. Now next is 40. So we know that it is what? 12 and 20 here. Then 10 is here. Then in between there will be a 15. And here it was 30. And with that we need to combine what? A 40. So the next is what? A 50. So how it is going to be stored? That is 50. So 50 is what? Next to 40. 50 just will compare here. It is greater than 20. So it will move right side. The 50 is again greater than 40. So it goes here. So 50 cannot be accommodated here because 3 keys will be there. So this is 40 is the middle one. So it will just move up. If it is going to be move up, then what happen? Again 3 keys are there. So again it's not allowed. So what happened? The 40 cannot be there with that. So again 20 will goes what? Move up. So here we can just rearrange it like this. The 20 will goes up as a root node. Now the 12 and this 40 again cannot be combined because 15 is there in between. So what we'll do here, we'll create a one node that is called a having a value what? A 12. Then the right side is having the value what? The 40. Now this is 10 and 15. So 10 should be left side of this. 15 should be here. Now this is 40. So left side is 30 and right side is what? A 50, which is new added. So you can see that all the properties of B tree is going to be satisfied. The order 3. So each node is having children 2. Now we can see that keys are also is not going to be there more than 2. So it is going to be satisfied. So in this way you can go for the B tree. We will see one more example. Construct a B tree of order 5 and this is given. This is alphabet. So you can see that A, G in that one. It is not in a sorted. We'll sort it while we are entering it. So the first, the node is empty or tree is empty. Order is 5. So 4 key is there. So what we'll do, first we'll take a first 4 A, G, F, B and it is going to be stored in a order. So A, B, F and G. The next is what? A K. So next is K, then it is going to be here greater than, but the 5 keys are not possible because order is 5. So F. F is what? A middle one which is going to be moved up. So this is up and left subtree is AB and right is GK. Next is what? The D. So where it is going to be stored. So this is greater than the less than the F here and it is going to be stored here. The D. Again H also it is considered because it is greater than, so move here and G, H. M. M is also greater than F, so accommodate here. Now J. Next is what? J, it is greater than F, so goes here and J is here in between. So what happened? It has to move up because the 5 key cannot be possible. So J is here, again it is going to be up, so F and G are combined. Now you combine it, so what happened here? G, H, K, M. So it is not going to be in a one node, it is going to be a separate one because the key is what? Whatever GH, it is less than J. That's why. The next is what? E, S, I, R. So they directly going to be accommodated. E is less than F, so move left side and stored here. Then I will be here and S and R is going to be here. So in that way it is going to be there. Next is X. Again it cannot be accommodated here. So what happened? We need to just move up. So R is going to be moved up. The next is what? We can say the C. It is going to be accommodated here. But the 5 keys is again not possible. So it is just move up. So C, F, J, R. Now this is the tree at this level. The next is what? L, N, T and U. This 4 we are going to consider. So L is directly accommodated here. N is going to be with that only. And then T and U. This is going to be at the last node. Now next is remaining is what? The P. So where it is going to be accommodated. So first we need to check here where the P is going to be there. So P is going to be here, greater than J and less than R. But P cannot be accommodated here as it's became what? The 5 values. So P is that. So last position of P. So again what happened? The middle key M is going to be up. Again at the upper level you can see the 4 key is already there. So 5 cannot be there. So the whatever the middle key is there, that is going to be up. So we know that J is a middle key that is going to be up and the whatever the tree is there, it is going to be constructed. So in this way the B tree is going to be constructed. Thank you for watching this video.